Yeah, okay, great assist there, jerks. Everybody say hello to my 7-8 class. Say hello. Do you have a friend in your 7-8 in my 7-8 class? Do you have a friend? Yes, say hello to them right now.
Hey, Maddie.
That was Julia. Okay, the rest of these people are silent mannequins. They might be zombies. Good Lord. I said, if you have a friend, maybe I shouldn't. Maybe you don't have friends, and that's part of the problem. I'm sorry. I should not make fun of you for not having friends. I'm sorry. That was cruel. Okay, but you could have said anything. You could have. Anyway, whatever. All right. So we're gonna sketch this ellipse. The problem is this ellipse is not in standard form, right? What does standard form look like? Standard form looks like this. Right? This is like having a podcast. They can only hear your voice, so you can't use like gestures or like actions because they can't see that. That doesn't translate into the audio, universe. So I just put a blue box around the standard form here. In standard form, we have squared binomials of x and y. We have fractions, and we have an equation that's set equal to 1. This setup has none of those things. It doesn't have any squared binomials, it doesn't have any fractions, and it is not set equal to 1. So we have to go to work. We have to get some squared binomials for x and y. How do I know that I'm going to get squared binomials for x and y? Because I have x terms like this, and I have y terms like this. That 1 that's on the other side of the equation, that's going to come from that constant value there, right? So what we're going to have to do, rather than drawing this out, we're going to have to complete the square for x and y at the same time. Okay? So here's the process. You ready? We take our x terms and we write them together. We do a little rearranging here. We take the 9x squared, we take the minus 54x, and we put them together. Okay? Now I'm going to leave a space here, right? Because that's where the completing the square starts to kick in. I'm also going to take the y terms, the 4y squared and the 40y, and I'm going to put them together separately on the same side of the equation, but separated from the x terms. Then I'm going to take that constant 37 and I'm going to move it to the other side. So I'm taking this and I'm moving it away. I want the terms that I'm going to use to complete the square, I want them all on the same side of the equation. I want the constant on the other. Everybody okay with that? Okay, now, in order to complete the square, we cannot have coefficients for our squared terms. We're going to do this at the same time, okay? So the first thing we have to do when we start this process is factor out whatever coefficient we have for x squared. Even if it's not a factor of this, I still have to get it out of the expression. So I move the 9 out. I've got x squared minus. If I factor a 9 away from 54, I get 6. And I'm going to close off the parentheses with that space that I had before. Okay, we're going to have to put a number there. I'm going to do this at the same time with the y terms. I'm going to factor a 4 away from y squared, and that means I'm factoring a 4 away from 40. That leaves me with a 10. I've got a space here as well, and that's equal to negative 37. So, in order to complete the square, you cannot have coefficients for your squared terms, right? And then we complete the square. How do we complete the square? We take half of this number, which would be what? I'm not going to ask. I'm not going to ask them because I know nobody's going to say the answer, so I'm just going to keep talking. Half of negative 6 is negative 3, and then we square negative 3, and we get positive 9. I do the same thing over here in this quantity. I take half of positive 10. Half of positive 10 is 5. 5 squared is 25. So, I introduced new terms into both of these quantities, terms that were not there before. The stuff that's in red wasn't in this original part of the expression. So, because I'm adding terms that weren't originally there, I'm altering what this problem, what the value of this entire expression. So to undo that, I'm going to balance it out over on this side of the expression, right? Now, I wrote a plus 9. I didn't add 9 though. Listen to the syntax. Listen to the words that I'm saying. I wrote a plus 9, but I didn't add 9. I actually added 81 because of the 9 that's on the outside of that expression. So I added 81 to the left side of this equation. So in order to balance that out, I have to add 81 on the right side. So you see the 81 on the left, now I have an 81 on the right. I have a plus 25 here. All right, I can't point to it. I have to do something there. There we go. I have a plus 25 there, but I didn't add 25. I wrote a plus 25. I actually added 100. So I have to add 100 on the right side in order to maintain the balance. So these terms that are over here, I had to add to maintain the balance of this equation. Now I can start to simplify what I have. Okay, I've got the 9 on the outside. I can write this trinomial in its factored form, which is x minus 3 quantity squared, plus I have a 4 outside this quantity, that's y plus 5 quantity squared. Where am I getting the minus 3? The minus 3 is what I got when I divided that by 2. The plus 5 that's here is what I got when I divided this by 2. Those are the numbers that end up in those binomials that are squared. On the right side, I can now add those constants, negative 37, 81, and 100, and I get 144. So now we're in a situation with this problem that was very similar to, this problem, right? When we started this one off, I had some squared x and y's, and I had a constant on the other side, but it wasn't equal to 1. But standard form of an ellipse, if I want to graph it, needs to be set equal to 1. So we divide by 144 to do that. Let's clean this up. I explained to you in the previous problem as well. The shortcut to this is not to try and reduce 9 divided by 144, but actually do 144 divided by 9. And 144 divided by 9 is 16. That means my denominator is going to be 16. Over here, 144 divided by 4 is 36. That's my denominator on the bottom, and this is equal to 1. So this is how we complete the square in order to get this into standard form. Dave.